Good morning, everybody. Thanks for making the time to be with us this morning. My name is Tom McMeekin. I'm a solutions architect at Databricks, based in Melbourne. And today I'm going to be joined on stage with Alan Cuthbertson, who's a senior manager and distinguished engineer at National Australia Bank. And today we're going to be talking a little bit about what it takes to adopt serverless at scale. We're going to be talking about some new concepts from a Databricks perspective. And if you think about from a serverless standpoint, we've been talking about serverless for a number of years now. But it's where our core key product innovation is continuing to take place. And so you've seen over the last couple of days some great announcements within the keynotes. And this is actually being powered by serverless from a compute standpoint. And so today we're going to be sharing how one of our leading financial services customers, National Australia Bank, have approached their serverless adoption, how they've looked at taking advantage of this innovation that Databricks is continuing to release to our customers. Now, I think their journey provides some great proof points, some great lessons learned, and some really good insights for hopefully you can take away today and apply to your organization tomorrow. I'm going to be spending a few minutes up front just to talk a little bit about what we're seeing from an industry perspective, and then I'm going to hand it over to Alan, who's going to take you through their journey and share a little bit more about where they're looking to head to next. But first, I thought it'd be worthwhile just drawing your attention a little bit to a soundbite that's been released or published as part of our recently published Financial Services Outlook for 2026. In here, we call out a major shift, and in that being roughly 94% of customers are now piloting generative AI or agentic AI workflows across core business functions like cybersecurity, risk, pricing, and personalization. So when I see this number, I see this as no longer AI being a key differentiator, or piloting AI no longer being a key differentiator, but in fact where the competitive advantage is really starting to be shown with our end customers is the ability to deliver and execute. And so you heard from in the keynote today, in fact, where Casey drew to calling out how teams are stuck building infrastructure to run their agentic workloads. Now, the key divide can be driven by both from a technical and a non-technical aspect, but at some point within this journey for customers comes the key question around, can the platform support their data and AI at scale? And this is where serverless plays a key role. And so when you think about the traditional data stacks that have been adopted by customers over the years, they've been built for historic reporting and retrospective batch analytics, not this continuous AI-driven workload patterns that we are seeing being attributed on the platforms today. And we've seen at Databricks internally and also with our customers this change of the shape of how customers are using or seeing their platforms being utilized over the last 6 months, where agents are now becoming one of the #1 users that are driving queries within your platforms. And what this means from a platform perspective is the requirements have shifted. No longer you need to build a platform just for the personas around data engineers, analysts, and scientists, but you also need to think about how agents are going to be inspecting or interacting with your data platform as well. And this is being driven from a continuous fashion also. So while this platform shift is probably not a surprise to you, one of the challenges that we see customers challenged with is how do they preserve or support this shape of queries and shape of workload patterns without fragmenting their data estate and AI estate. Being able to apply consistent controls, auditability, and lineage across their data that is being reasoned from across with their agents. So serverless can help simplify this by providing execution fabric across any type of workload pattern. Think of it as that single execution layer. Additionally, from a serverless perspective, it enables customers to take advantage of the pace of innovation that Databricks is continuously providing to customers. As releases are made available within the platform, from a serverless perspective, being evergreen and versionless, you can take advantage of these new features without having to think about the infrastructure upgrades that you need to take place from a classic perspective you might have to do today. So when customers first start their journey and thinking about how can they adopt serverless within their environment, we often spend a lot of time with customers up front to build the trust and confidence of how the platform will scale within their organization. So serverless brings a shift in the shared responsibility model where the boundary leans more towards Databricks as we're taking on the ownership and the run of the underlying infrastructure. So think of things like virtual machines, the DBR management, network infrastructure, and also scaling to support your workloads. Now, at the center of this is Unity Catalog. So think about Unity Catalog as that connected tissue across governance for your data and AI. And so as you embark on your serverless journey, it allows your teams to focus more on the things that really matter, that is underpinned by Unity Catalog. So these are things like identity and access, policies, audit and lineage, but also, most importantly, workload design as well. So, and as the agentic demand grows and the shape of the queries are continuing to, I guess, exponentially grow from an agentic reasoning perspective across your governed data, so too the guardrails need to scale with you on this. And this is where serverless can help. So let's now bring this to life a little bit. And in my mind, I think the real proof in the pudding is actually hearing from a customer who's gone through this in the real world. And so what does it take to adopt serverless inside a bank across some critical workloads, also but respecting the security controls and governance requirements that a regulated organization need to adhere to? So I'd like to now invite Alan to the stage. He's going to share through the journey about how they've approached serverless adoption, working closely with their security and risk teams, and scaling across their organization. Alan, over to you.
Thanks, Tom. Yeah, it's my pleasure to take you through what we're doing at National Australia Bank, how we're using Databricks to build out our strategic data platform in a highly regulated industry. So first, to set the scene a little bit, NAB is the second largest bank in Australia and the largest business bank. For 170 years, NAB's been helping our customers with their money. We work with small, medium enterprises and big businesses to help them start, run, and grow. We serve a customer base of 10 million at around 700 locations in Australia, New Zealand, and around the world. I'm proud to be part of a large workforce as one of 38,000 colleagues. And ours is a large business. We're truly data-driven. We have a lot of data to work with, and it's a critical resource in every part of the bank. So a few years ago, we had a vision for a brand new data platform, and there are 4 key reasons why we decided to embark on this journey. Firstly, we needed to simplify. Our platform at the time had dozens of technologies, Teradata, Redshift, EMR, Snowflake, Informatica, Airflow, the list goes on. Some of these were modern at the time, but the overall solution was fragile, it was complex, and it had scalability issues. So we needed to standardize. Patterns on the system at the time were use case driven. This led to lots of different paths through the system and a choose-your-own-adventure kind of style. We needed stability and reliability. Data transformation logic wasn't visible. We needed transparent lineage end-to-end, and there was limited monitoring and alerting capabilities. And finally, scalability. We had to... Sorry about that. Oh, good. Yeah, sorry. Scalability. We had to build a system that would last for the next 5 to 10 years. So to build this data platform with kind of 3 building blocks. Firstly, a really clear data strategy that the business could understand. NAB's data strategy is to deliver data at speed, at scale, in a secure way. Data is fundamental to how we serve our customers and how we operate. Data like electricity. What do we mean by this? It needs to be reliable and continuously available for everyone. Secondly, we needed leading-edge technology that's future-proofed. Databricks is the cornerstone of how we're going to power NAB's data strategy. The powerful thing about using Databricks is that everything's in the same place compared to existing approaches where we had to rely on copying, extraction, integrations, and managing all the spaghetti in between. Finally, people. So NAB's got a lot of experience running cloud applications and platforms, as well as traditional database and data warehousing skills. But Databricks in itself is a skill. So we've partnered with Databricks not just on the platform, but also on training. We've made extensive use of the Databricks Academy, as well as classroom focus sessions to ensure that our analysts, machine learning engineers, platform engineers, data engineers all get a Databricks certification before they get access to the platform. And we find that that combination of self-paced learning and classroom-based gives the right mix of kind of technical and NAB-specific training. And again, building a Databricks platform needs multidisciplinary teams that are curious and keen to learn new skills. We've partnered really closely with our account teams, as well as the product teams in San Fran and Amsterdam, to ensure that our requirements feed into the Databricks roadmap. So this is how we engineered Ada, which is our lakehouse, and how we get to data like electricity. So if you look at this diagram from left to right, the platform's only going to be as good as the data that we put in it. It's going to power our bankers and our customers and our strategy to be the most customer-centric company in Australia and New Zealand. So we go to systems of record and extract everything of business value. We've got a hyper-standardized small number of ingestion patterns to ingest from the top 200 sources in the bank. We use Fivetran SaaS for software as a service sources like Salesforce and Workday. For relational databases, we use HVR for non-invasive access to the database logs, and that allows intraday change data capture. This is a game changer for us and for a lot of companies that are used to a kind of end-of-day picture in a traditional data warehouse. And then for file-based sources, we use Autoloader and Databricks Delta Live tables, or Spark declarative pipelines, as they're known now. And the Lakehouse itself is built in a medallion architecture with bronze as a raw, like source. All the conformance and transformations happen within Databricks, and we've gone for a conformed third normal form IBM reference model in silver. And then our gold model is a semantic layer that's modeled for business usage. At the heart of all is Unity Catalog. Unity Catalog solves a number of problems for us for data governance, user access, data lineage, and making sure that people have access to the data they need when they need it, and they know exactly what they're working with. Every attribute we load into our Lakehouse gets metadata captured and tagged, and we sync that metadata between Unity Catalog and Calibra, which is our enterprise data governance tool. This also allows us to deploy our own fine-grained access control. And on the right-hand side, from the consumption side, we've got over 1,700 users of a greater than 1 petabyte Lakehouse with pipelines running continuously. We've got data scientists that are familiar with Python and comfortable using the Databricks notebooks that's got ML flow baked right in there. And then we've got data analysts who are more used to querying relational database systems. They use serverless SQL warehouses that spin up and spin down as peak rises and falls. We visualize all of our performance metrics using AI BI dashboards and Power BI. And now our users are querying the data using natural language in Genie spaces. So as I said, at the heart of our Databricks implementation is Unity Catalog, a single place to govern everything in Databricks, including all of our regulated critical data elements. So the next logical step in our journey was serverless compute, and allowing serverless Databricks compute to access data in our data plane and our other resources in the bank. And as Tom mentioned, adopting serverless opens up an array of innovation from Databricks. In our case, we took a methodical approach to migrating across to serverless, and in the next few slides, I'll run through how we've gone about it. So before we could migrate anything to serverless, we had to do a number of assessments as part of the approval process. That involved a third-party risk assessment, customer risk assessment, security architecture review, and we also had to work with one of our regulators. We had to prove a number of key controls were in place before we could get the green light for a box number 2 on the diagram here. Things like internet on-off, serverless egress control policies, and budget policies. So Private Link lets traffic between your users and Databricks, as well as between Databricks control plane and your data plane, stay on the cloud provider's private backbone with no public internet at any point. So that's essential requirement for our regulated workloads, and it lets us realize the full potential of serverless and streamline all of the platform capabilities that are going to use it. It's necessary for us to connect to other services in the bank, like GitHub for code, Artifactory for packages, and HashiCorp Vault for secrets. So we had to work closely with Databricks and our security, network, and cloud architects to design and deploy it. So once all the infrastructure was in place, we began a phased cutover of all the workloads that we identified as benefiting most from serverless. The first use case that we migrated was serverless SQL warehouses. And why would you choose serverless SQL over classic or pro? From the infrastructure management point of view, in serverless, Databricks just manages the compute fully. Whereas in pro, you've still got to manage min-max cluster sizes, fiddle with knobs, configure it the way you want it to be. From a startup and latency point of view, serverless is typically faster from a cold start, and it's got better interactive responsiveness for the users, whereas pro can be slower to start up, depending on how you've configured it. On auto-scaling, again, serverless is more automatic and fine-grained, whereas pro has got good auto-scaling, but you need to do more manual tuning. And from a cost model point of view, serverless is great for like kind of bursty BI workloads. It results in less idle waste time. Pro can be cheaper for some steady, predictable workloads, but if you tune it well, but it's easier to waste money if you oversize clusters and leave them running. So what we did is we've migrated 1,500 users across to serverless SQL warehouses across 20 domains. We segregate our users by domain, so each domain has one or more SQL warehouses. You set the t-shirt size for the new SQL warehouses, you do some simple config, you work with the users to move things across, monitor performance, then switch off the old stuff. It was a really seamless transition. For serverless notebooks, serverless compute helps most with the developer speed and platform simplicity. You've got instant-ish start with less waiting time to attach and start clusters. There's no cluster admin work, so there's no sizing, no patching, no DBR upgrades for most use cases. It auto-scales by demand, so it's better for spiky, interactive workloads. It's also got better utilization, so that avoids any idle personal clusters that are just sitting, running out there. It's faster to onboard new analysts and engineers. You can just run notebooks without having to know cluster config and cluster setup, and you get far few, this thing works on my cluster type complaints. So to summarize, it's great for exploratory analysis, lightweight feature engineering, SQL, Python notebooks with intermittent activity, and it's really good for large analyst communities. A couple of things to watch out for. It can be less flexible for kind of highly customized libraries, system configs, that kind of stuff. It can be costlier for long-running, always-on heavy compute versus dedicated clusters, obviously. You do have to check if you've got any specialized networking or security constraints or data that you want to access from the serverless plane. But I'd say as a practical rule, default all your notebooks to serverless and only carve out dedicated clusters for really specialized heavy jobs. And again, we've migrated hundreds of analysts, data engineers, and data scientists across to use these. Now, for people that haven't used Delta Live tables or Spark declarative pipelines, as they're called now, this is kind of what they look like. You declare them through code, and then you see a graph like this in the Databricks UI. So we began our journey by standardizing all of our bronze pipelines to use SDP. We onboarded 120 data sources in the first year, and today 100% of our bronze pipelines run in SDP, and about 50% have been migrated in silver. Our long-term goal for declarative pipelines is end-to-end stream processing from bronze all the way through to gold. Declarative pipelines enable incremental processing, built-in change data capture, instead of reprocessing entire data sets. Pipelines only process new and changed records, so that reduces cost, improves performance and reliability. Lakeflow's built-in CDC capabilities, including auto CDC, again, eliminates the need to hand code any slowly changing dimension logic that you've got in your Spark and SQL, so it just simplifies things. And we've seen some real tangible outputs from this process. Latencies drop dramatically. We've got some use cases now running 15 minutes end to end all the way through the Lakehouse. Success rates have improved. Data quality has improved. Onboarding engineers is faster because we've got one framework to build on, and we've significantly reduced the cost of our kind of bronze and silver pipelines. So a little bit about Genie Code. After we migrated all the users to serverless SQL and serverless notebooks, we enabled Genie Code for analysts, data engineers, and AI engineers. That was probably about 6 months ago, and now I looked at the stats today, and half the people that access our platform use Genie Code this week. So almost everyone's using it. The big advantage Genie Code's got over other coding assistants that we've got in the bank is it's got access to everything that the users get access to in Unity Catalog. So that gives a huge advantage over Claude, for example. We've had really good feedback from the user community, and they just want more. So it's landed really well. Serverless also powers our AI stack. So the Databricks AI Gateway, which is part of the Mosaic AI model serving, is a serverless governed entry point for all your LLM and ML model traffic. So instead of letting every app call OpenAI or Anthropic or any internal models directly, all of the calls flow through a single Databricks managed gateway endpoint. It runs fully serverless, no clusters, no infrastructure to manage, tightly integrated with Unity Catalog, ML Flow, and all the Databricks governance. So this is a kind of high-level architecture of the AI capability that we've built. There's two main goals that we set out to achieve with this. One's to build, test, and deploy a given use case all in the same place. Two is to be as self-service as possible, while still providing all the different capabilities needed to develop AI use cases in a safe and secure way. As you can see, we've used quite a few Databricks capabilities to provide a kind of seamless integration between the different components. That enhances the developer experience. It means you can quickly and easily test and compare different LLMs against each other. And we're also utilizing Databricks apps to bring the application to the data. So we've said a few times today that serverless gives us access to the newest innovations that Databricks have on offer, and we're constantly working with our account team to see what else we can use. So a few recent examples, first being Lakewatch, the new kind of security incident and event management platform. All the jobs in Lakewatch are fully serverless. So we've recently announced a design partnership with Databricks on this product, and we've been working with them for the last few months. And there's a lot to come in this space. I think it's a massive opportunity for kind of both companies, so there's kind of watch this space. Lakebase, we've heard a lot about this week. We're using it for online feature stores, and we're looking to migrate some of our ODS use cases across to Lakewatch, Lakebase. And then from multi-region and multi-cloud disaster recovery, it clearly becomes a lot easier the more serverless processes that you run. If you're not managing your own compute and you give Databricks permission and access to more, then you can work closely with Databricks to manage your DR solutions. So that's something that we've got on the roadmap as well. Thanks very much, and back to Tom.
Thanks, Alan.
All good.
Nice one. So just a few comments from myself before we close up the session, and we'll take some questions. So the next wave, or the current wave and the next wave of innovation is continuing to take place in serverless. And so if you haven't started your serverless journey today, then I highly encourage you to reach out to your account teams, and we're here to support you in addressing any questions you might have about it and building the trust and confidence around your serverless adoption. Exactly what we've done with National Australia Bank to help them achieve some of their great success goals that Alan has spoken about. And the platform is no longer just built for the traditional personas. So there is a new persona that you also need to think about and how you can scale your platform to support this. And this is the agentic workflows powered by Genie agents or directly through MCP integrations. We're seeing a huge growth and shift in the shape of how data platforms and Databricks is being utilized to support customer use cases. And also the real unlock in enabling seamless compute execution layer is Unity Catalog as well. And so this enables your teams to have confidence around the different types of compute that is being utilized to support the various type of workloads, having consistent controls across each of those domains to enable you to have that full single place to have that control and full visibility and auditability. So just wanted to also leave you with just a few reference points for potentially it might be of interest for you to double click further today. There's a great blog article that our platform engineering team have released around a little bit about under the hood look at how they built serverless and this notion of versionless and also decoupling the client to the back-end compute. Highly encourage you to double click on that if you're interested. And then also from a higher level perspective, looking at from an industry standpoint within the financial services industry, the financial services outlook and key trends that might resonate with yourself and help you define some of the key challenges or opportunities that you could potentially partner more closely with from a Databricks standpoint. And lastly, we're very lucky to have National Australia Bank here presenting a number of sessions across the summit today. So this is one of 3 sessions that the team are spending their time and sharing their knowledge and learnings to everybody here. We've also we had a session yesterday, so that was recorded, so that will be available to you as part of the virtual summit. And then shortly after this session here, the National Australia Bank team are sharing their Genie adoption story in the Moscow and West building, if there's interest in following us across there. But certainly that will be recorded and made available after the summit as well.